Alright guys, so this week I just decided I was going to make videos instead of just doing notes. Hopefully this will help some of you that maybe struggled last week with the information. So we're going to start with find explicit and recursive formulas. So explicit formulas basically in layman's terms is how do I find each term in a sequence? It answers that question. A recursive formula, however, is basically how do I find the next term in a sequence. Okay, so the key word is next versus each. Okay, like I said, in explicit we'll find each term, which means that every number or every term in that sequence has a term number, which you use for this one. The term numbers matter, but they don't matter for this one in the instance that I do need each number in the sequence to find the next one. Okay, so it says the first 6 terms of a sequence starting with a sub 1 equals -3. So I have -3, 5, 13, 21, 29, 37. It says find this recursive and explicit formula. Recursive is easy. So our recursive like I said is easy. So how do I find each following term in the sequence, right? So from -3 to +5 is +8. 5 to 13 is +8, +8, +8, +8. Okay, so that means I'm adding 8. So a sub n is equal to a sub n minus 1. And how do I find the next term? I add 8. Done. This is my common difference. Or how do I find each term? The explicit, a little bit more challenging, but still not that bad. Okay, so we'll create a little function table over here because basically the explicit is a function table. Okay, so our term number, or our n is here. Each of these have a term number 1, 2, 3, 4, 5, 6, right? 1, 2, 3. We'll just go down to 4. Okay? Each one is paired with a output or a sub n, which is -3, 5, 13, and 21. Right? This common difference is actually what we're multiplying by each of these by. So this is 8 times 1, 8 times 2, 8 times 3, 8 times 4. Then I also have to figure out how to get to here. So 8 times 1 is 8. How do I get to -3? I subtract 11. 8 times 2 is 16. How do I get 5? I subtract 11. That's 24. How do I get 13? I subtract 11. That's 32. How do I get 21? I subtract 11. So what you should notice here is that I have an 8 multiplied by my n minus 11, so my explicit a sub n in this case is 8 n minus 11. There's your recursive and your explicit. When every term number is the same, they're very easy. So recursive is that a sub n is equal to a sub n minus 1. This is when they are the same. What you notice is that I am adding 0 every time. Or, as you'll find out in the next video, or I talk about a little bit right now, if these were all a product, if it's a geometric, which it can, this type of sequence can be both. It's arithmetic because I'm adding 0, or it's geometric, which I'll talk about more in the next video, because I'm multiplying by 1 every time. Okay, so in this case I'm either adding 0 or multiplying by 1. Explicit, very simple, is that a sub n is just negative 2. Alright, that one was quick. That one was really easy. Alright, we got 2 more. So it says the first 6 terms of a sequence starting with a sub n equals negative 3. So we have negative 3, negative 12, negative 48, negative 192, negative 768, negative 3072. Obviously, since they are getting larger very quickly, this probably means that we are multiplying. So how do I multiply it from negative 3 to negative 12? Well, I multiply by 4. How do I multiply here? Well, I multiply by 4. Chances are that's going to continue. So I'm going to say, even without checking it, because I will tell you won't have to check it, that you are multiplying by 4 every time. Alright, so recursive again, very simple. A sub n is equal to 4 times a sub n minus 1. The explicit, like I said, a little bit more challenging, and it's also a little different from the other one. So so that's n. This is a sub n, right? So 1, 2, 3, 4. 1, 2, 3, 4, negative 3, negative 12, negative 48, negative 192. Okay, so this is going to work a little differently now. Since I'm multiplying every time, I want to think exponents. So basically I'm thinking like an exponential function, right? So from here to here is multiplying by 4. But from negative 3 to negative 48 is multiplying by 4 squared, or 4 times 4, 16, right? So in this case, it's now going to be 4 raised to the 1 2 is 4 raised to the 2. This is 4 raised to the 3. And this is 4 raised to the 4. Okay, well, 4 raised to the first power, right, is 4. I need to be able to get down to 3. Well, how do I take 4 down to negative 3? I'm going to multiply this whole thing, right, by negative 3 over 4. Okay, that way the 4's cancel, leaving me with the negative 3. So the explicit a sub n is now negative 3 over 4 times 4 to the n power. Because again, this would be negative 3 over 4. This 4 will cancel with one of those, leaving me with negative 12. Negative 3 over 4, and again, negative 3 over 4 each time one of the 4's will cancel and allow me to multiply just the number of 4's that I need by the negative 3. Alright, so the first 6 terms, okay, so again, so now this one's going to look a lot like that one. So negative 6 to get to negative 12, to get to negative 24, so on and so forth. I'm now multiplying by 2. Alright, so recursive in this instance is that a sub n is equal to a sub n minus 1, or, sorry, two times a sub n minus 1. And explicit is a sub n is equal to, well, if this is 2 to the n, right? So if I come over here in a sub n, whoops, wrong one. Say 1 and 2, negative 6, negative 12, right? This is 2 to the first, which is 2. How do I get negative 6? Let me scoot that over. 2 to the 2 to the first, how do I get negative 6? I multiply by negative 3, right? So this is 2 squared, which is 4. How do I get negative 12? I multiply by negative 3. So this is going to be negative 3 times 2 to the n power. Okay, so I hope this video helps with the explanation and so on. We'll talk to you guys in the next one. Bye.